Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Dark Reading webinar, AI versus AI, the good, the bad, and the ugly, sponsored by Deep Instinct and broadcast by Informa. I'm Peter Krause with Dark Reading, and I'll be your moderator today. Before we get started, I have a few very quick announcements. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session that will take place at the end of the webinar. The slides will advance automatically throughout the event. You can also download a copy of the slides via the resources widget. Toward the end of the webinar, I'm going to ask you to complete a survey, and that's found on the right hand of your screen. We hope you'll take a minute to complete this survey before you leave us, as your feedback will help us to improve future events. And finally, if during this webinar you have any technical issues, please click the Help widget. That's at the bottom of the screen. Or you can type your issue into the Q&A. Either way, we'll be glad to offer one-on-one assistance. And now let us move on to our presentation, AI versus AI, the good, the bad, and the ugly. Discussing today's topic, we have some guest speakers. We have Nadav Mamon. He's the CTO and co-founder at Deep Instinct. Nadav has over 15 years of experience in customer-driven business and technical leadership. He's managed technically complex cyber projects, including design and execution, and pre- and post-sales. Nadav has hands-on experience with data security, network design, and the implementation of complex heterogeneous environments. Previously, Nadav was an intelligence officer in a well-known IDF technological cyber unit for 5 years. He was recruited to Israel's top technology intelligence unit, where he led the design and establishment of military data security infrastructures. After Nadav's presentation, we'll have a short interview with one of Deep Instinct's customers. That's Bruno Mariano of King's Food Markets. But for now, I'm going to hand it over to Nadav.
Hey everyone, I appreciate your time on this session. During this session, I will try to provide with an objective overview on the adaptation of machine learning capabilities into the attack landscape. So I would like to first start and discuss deep learning in general and the difference between machine learning and deep learning. So generally speaking, most of the companies today are already using AI. It's available actually since, I would say, the late 50s, but more accurate to say that classical machine learning are available since the 80s, which we are referring to AI techniques that give computers the ability to learn without being explicitly programmed to do so. When referring to deep learning, it's a subset of machine learning which makes the computation of multi-layer neural networks feasible. So what is the difference between machine learning and deep learning solutions? When using classical machine learning solutions, we are actually referring to the raw data, to just 2% of the available data. By just going over the potential domain that we are analyzing, in the case of cybersecurity, by just looking on the malware and trying to analyze specific features, we are actually losing significant amount of the data. By just doing feature engineering and assigning a dedicated domain expert to extract the relevant attributes, we are actually always relying on the known attacks and known campaigns without letting actually the machine the option to run completely autonomously on 100% of the data. By using deep learning, we are actually skipping the phase of human intervention, and without any pre-processing, we can actually feed the raw bytes to the deep learning framework. Looking on the market in general, the best example from the image recognition world of Envision and the world of computer vision challenge, the most common benchmark in the market is definitely a publication done by Microsoft on a well-known data set called ImageNet. State-of-the-art results with classical machine learning algorithms up until 2010 on this data set were 25% error rate, while us as humans are capable with 5% error rate on the exact same data set. Microsoft published a great paper and reached 3.57% error rate on this benchmark, and actually prove that the machine can do better than human with recognizing an object inside a picture. An actual improvement of 20 to 30% in each and every domain, either image recognition, as I just mentioned, but also in speech recognition and other domains. Actually, IBM couldn't develop these capabilities in-house, and they needed to acquire Alchemy API in order to improve what's in the specific domain of bioinformatics. I believe that most of the people are well familiar with Deep Blue, who won its first game against the world champion during 1996. But when it defeated Garry Kasparov, and indeed the machine won in the first game, but then in a competition of 6 games in a row, it actually couldn't win the whole series. And then after an intensive improvement, more than a year later, in 1997, it was the first time ever in which the computer system was able to defeat a resigning world champion in a match under standard chess tournament time controls. This was the first time based on, I would say, classical machine learning algorithms. But then, of course, Google raised the flag on the next challenge. In this specific slide, I'm referring to a use case that I'm sharing with you. It's a challenge that couldn't be resolved with classical machine learning algorithms because of the complexity of AlphaGo game. This AlphaGo challenge match is definitely considered as a milestone with deep learning capabilities, when as human, we are doubting the machine capabilities versus human capabilities. So what is the challenge of implementing deep learning into cybersecurity? There are a few different domains. I'm not going to dive into details in this session, but you can definitely approach us after this session and ask any question, either from over our website or over email. The first point is during the training cycle, overfitting, of course. Overfitting is an issue within machine learning and statistics. It occurs when we build models that closely explain a training dataset, but fail to generalize when applied to other datasets. Another interesting challenge is when using representative training data. Huge volumes of data, in our case, in most of the cases, hundreds of millions of samples during each training cycle. The challenge of this data being representative data required to prevent underfitting, and also public repositories may not be representative. Last point during the training cycle is using the right training methodologies. Applying machine learning to security is almost trivial. Applying machine learning to security with meaningful results is highly non-trivial. Of course, with the inference model in production, the challenge of updating in an efficient performance, and of course, dealing with different file sizes is of course another challenge if you would like to bring to the market a prevention solution which is working in zero time. Generally speaking about the process of the training, we're relying on more than 60 different resources as a part of our training cycle. We are dealing with third-party public sources. We are looking into specific tools which are available in some of the cases in darknet, in some of the cases in other forums. We are developing some of the malware in-house, and we are mutating malware. So all in all, we are dealing with more than hundreds of millions of files in every training cycle, but we are taking these hundreds of millions of files out of more than 2.5 billion files that we have in our repository. During the entire training cycle, we're using any kind of file, completely agnostic to the file type, and the output of this training cycle is actually a small light version of the brain. It's actually the inference model, which can then label each and every file and update the customer if it's malicious or not, and of course take a decision on device if we are preventing the potential malicious attack. So what does an AI-based attack look like? So in Deep Instinct, we are breaking it into three main use cases. We'll just speak about it briefly, and then I will dive into each and every one of them with specific use cases. Generally speaking, when we are speaking on AI-based cyber attacks, the malware operates AI algorithms as an integral. Second use case is an AI facilitated cyber attacks, which use of malicious AI algorithm to subvert the functionality of benign AI algorithm. And the third one, which is adversarial neural network, and let's dive into each and every one of them. Speaking about AI-based cyber attacks, it's a use case in which the malware operates AI algorithm as a part of the business logic. In the past, such decisions could only be made manually by a human, as opposed to today, where it's able to be generated automatically. The attacker is actually attempt to leverage the outstanding abilities of machine learning and deep learning to perform what was once not able to be done in an autonomous manner, but this time autonomously, such as sending data based on a decision driven by a machine learning and deep learning installing itself on specific endpoint or machine based on autonomous description and running itself based on machine learning or deep learning. The best use case that I can share in this forum is the use case of DeepLocker. DeepLocker is actually a ransomware which autonomously decides which computer to attack based on a face recognition algorithm. During this session, I'm not going to dive into each and every component of this attack, but it's a proof of concept done by IBM as a part of Black Hat 2018. When an attacker is looking for targeted attributes, it can be a physical environment, audio, visual, software environment, user activity, or geolocation. In this case, only when the target is recognized by the camera, of course, after using face recognition techniques to identify it, the attack takes place. The next category that I'm going to discuss is an AI-facilitated cyber attacks. For instance, an infostealer malware which uploads a lot of personal information to a potential command and control server, and then an LLP algorithm is used to classify the information as interesting. For example, credit cards, passwords, confidential documents, etc. Another example which can be, I guess, an example that most of you are familiar with will be the fapping attack, where iCloud leaked celebrity photos. Such an attack can or could have taken place in a much larger scale if it was an AI-facilitated attack. Imagine that based on computer vision, machine-based algorithms, the attackers could use millions of pictures and identify which of them contain celebrities and then expose only the interesting ones, similar to the ones that are leaked in this campaign. Another example of AI-facilitated cyber attack is spear phishing. The most advanced spear phishing attacks require a significant amount of skill level, as the attacker must identify suitably high-value targets, research these targets in the social networks or professional networks, and then generate the message that are which are based on the context will hit the target. Social network, especially Twitter, with its access to extensive personal data, bot-friendly API, and shortened links, are the perfect venue for spreading machine-generated malicious content. In this specific example, you can see that ZeroFox Labs presented a recurrent neural network that learns to tweet phishing posts targeting specific users. The model is actually trained using spear phishing pen testing data, and in order to make a click-through more likely, it is dynamically seeded with topics extracted from timeline posts of both the target and the user that retweeted or follow. I will not dive into each and every one of the stages. In general, as you can see, an attacker can easily export all the associated data as of personal information, historical profile posts, text, images, URL, etc. In the second phase, it's very easy to be focused on the relevant default settings or the following followers, description content, account age, etc. And after selecting the relevant clustering model in the first stage to just look on the weaponized data science for social engineering. In this specific proof of concept, Zero Labs could reach almost 70% success in the click rate without any human involvement generating the exact targeted attacks. The last topic, which we find very, very interesting, probably one of the most interesting domains today in the industry, is definitely adversarial learning. What options an attacker has when attacking a machine learning-based security solution. Generally speaking, in this specific case, it's an experiment done on stop signs. Is placing a sticker in a strategic position on a stop sign, which, of course, each and every one of us can recognize the stop sign in both pictures, but unfortunately, with a minor change of just putting the sticker, it's very easy to impact the correct labeling of the machine with the basic image recognition capabilities. Actually, by doing this, we're causing it to be misclassified by an image recognition street sign classifier as a speed limit sign. Such attacking techniques have been developed against computer vision algorithms, mainly NLP, and also malware classifiers. The author trained a network, in this case, on the LISA dataset, US sign dataset, comprised of different road signs like stop, speed limit, yield, right turn, etc. And the classifier accuracy was 91%. More information can be shared after this session. So, how difficult it is to manipulate the machine? In this specific slide that I'm sharing with you, which one is which? So, interesting or not, I guess that if you are looking now on the screen, you can probably ask yourself, okay, so I see a panda on the left side of the screen, and I can see the same panda on the right side of the screen. So what is the issue? And this is exactly the difference between us as human versus the machine. State-of-the-art results with machine learning, even deep learning, can reach, as I mentioned, a high detection rate and low false positive rate. But you can see in the middle, in this specific experiment, a scenario in which just with a noise of 0.07%, a machine-based classifier, instead of labeling it correctly as panda, is actually labeling it as gibbon. In this specific use case, despite the approximation made, a model with close to the state-of-the-art performance on MNIST, it misclassifies 89.4% of this method's adversarial examples. So, adversarial machine learning what options do attackers have to attack machine learning? Actually, machine learning models should rely on training data sets that represent the wide production environment. So potentially an attacker can try to actively manipulate the training data or production data to lead to a misclassification. In this specific example, it's an example for poisoning attack called model skewing, where attackers attempt to impact training data to shift the learned boundary between what the classifier categorizes as good input and what the classifier categorizes as bad input. Attackers add samples to the training set skewed model, for example, public malware repository. And this is a real example from a specific period between November 2017 and early 2018. Again, real life example. So another potential action that an attacker can take is an attempt to manipulate the inference model. The attacker can try to get persistent in its targeted environment, retrain with adversarial examples or adversarial training by manipulating and changing the samples. Another interesting domain is, of course, GAN, when we are referring to two neural networks contest with each other. A scenario in which, given a training set, this technique learns to generate new data with the same statistics as the training set. For example, a GAN trained on photographers can generate new photographs that look at least superficially authentic to human observer, having many realistic characteristics. In this specific case, you can see paint, which was actually sold for more than $400,000, which was, of course, made by a machine. In May 2019, researchers at Samsung demonstrated a GAN-based system that produced videos of a person speaking with only single photo of that person provided. Actually, Jan LeCun, who's leading the AI group in Facebook, described GANs as the coolest idea in machine learning in the last 20 years. So how is that related to cybersecurity specifically? In this specific example, you can see a list of features from one of the leading solutions in the market, and I'm not going to, of course, share more than this. As it shows, features are defined using file size, JavaScript existence, page count, objective count, stream filtering, entropy, etc. The full list of features and the procedure of extracting are not discussed in this paper, but I just want to dive into each and every parameter and discuss the potential changes that an attacker can take and do. So potentially, if you're referring to counting how many executable sections are there, for example, if we're referring to loading points, what is the date of the modification? Potentially, if a classical machine learning-based solution will look on the normalization, you can ask yourself, okay, so what is the average entropy of these sections? Looking on binary features, is a string there? Is a file signed or not signed? Potential heuristics, which might be based on permissions. So an attacker can easily create additional code sections and influence the counting. An attacker can change the timestamps or pad the file with additional data, potentially add plain data. An attacker can also pack malicious functionalities and create certificates, potential evasion technique in order to bypass any heuristics. So the best question to ask is, do you really have a defense strategy in place? AI-based cyber attacks in the past, such decisions could only be made manually by human, as opposed to today where it's able to generate decisions automatically. Adversarial attacks against the usage of AI are possible, but not feasible. It's very hard today to evade a solution which is based on deep learning, which is completely agnostic to the input layer. But the attackers should know which features to use and know the exact models that the company is using, potentially by reverse engineer the model or use a predictive engine. Much easier to attack predictable high-level features such as those used by our competitors, which I just shared with you some of them. Nearly all published adversarial attacks are for image recognition today and not for cyber attacks, although there are also a few examples in order to evade some of the common solutions right now in the market. We have defense methods implemented in our framework. So speak in nutshell on Deep Instinct. Deep Instinct was founded in 2015. We were the first and still the only cybersecurity company to apply an end-to-end deep learning. We developed the entire framework of deep learning from scratch. We are not using any open source library. We provide our customers with full prevention capabilities. In general, looking on the solution, we are dealing with any threat. So any file-based threats that is available, we will immediately add them to the test set, to the training set, and mitigate. And we're looking on any ransomware, exploits, spyware. We have a multi-layered protection, so we are giving pre-execution capabilities to our customers based on static analysis engine and also reputation. And we do have also behavioral analysis capabilities, which are based on the execution. And of course, full post-execution analysis for malware classification, which is also based on deep learning, no human involvement. Our algorithms can label on the spot if it looks like malicious or not in milliseconds. And in case of a malicious file, we can also label if it looks more like a ransomware or more like a potentially unwanted application. That's it. I think that I will forward the session back to Peter.
Thank you, Nadav. That was fascinating and a bit frightening, so that was very informative. Thank you. Now, as I mentioned earlier, we're going to have a brief interview with Bruno Mariano. He's the Director of Technical Support and Services at King's Food Markets. And Bruno has nearly 20 years of experience in IT. He's worked in fields that include pharmaceuticals, finance, insurance, publishing, software, and now retail. His company, King's Food Markets, has been a customer of Deep Instinct since last year, 2018. So, Bruno, thanks for joining us today. And to get started, tell us a little bit about King's Food Markets and its relationship with Deep Instincts.
Sure. So King's is a regional food market. We're basically in the Northeast, northern New Jersey, New York, and Connecticut. We're kind of a niche grocer, right? We provide day-to-day products as well as those hard-to-find foodie products as well. But at the end of the day, we're a supermarket that wants to secure our data as well as our customer data.
Okay, and what are some of the specific security challenges that you've had to deal with?
From our point of view, it's a lot of where we've been targeted a lot for phishing campaigns, spear phishing, a lot of internal web surfing that users a lot of times might not go to websites that are approved per se that might infect the machine. So that's kind of at a high level the basic challenges that we faced when I first joined on board.
Mm-hmm. And can you tell us a little bit about the information security architecture there? What are you using, and against what kind of attacks?
Sure. So from our layout here is what we've set up is we use the Cisco Umbrella product initially for web browsing. That's helped mitigate a lot of issues for us. And then we also use Mimecast for our email. And then at the endpoint level, we're using Deep Instinct that we just migrated to last year.
Mm-hmm. And what led you to choose Deep Instinct?
So we were using another product prior to Deep Instinct that we just were not happy with. It wasn't that it did not work, but it wasn't as competitive in terms of attacking unknown zero-day attacks as Deep Instinct did. So in a dev environment, Deep Instinct really shined, and we made the jump.
Mm-hmm. And you've been using it since last year. What kind of results have you gotten from Deep Instinct?
Proud to say we haven't had any issues. So it's worked as advertised, so to say. Luckily, it's caught anything that's come through. It's never, anybody clicking on a spear phishing email that went to another site, it automatically shut that down. We've never really had to react to anything since we've put it in, so we're definitely very happy with the product.
Okay, great. Thanks. That's very helpful. All right, everyone. That's it for Bruno for right now, but we're going to move on to a general Q&A, so folks in the audience can ask questions to either Bruno or Nadav. Before we do get there, I would like to remind you about that webinar survey that I mentioned earlier. We really would appreciate if you'd fill it out. It's available on the right of the presentation window. If you close the survey, you can reopen the widget. To do that, you just click on the icon along the bottom of your screen. And thanks again for filling out the feedback form. Your participation will help us serve you better in the future. Now we're going to go on to our question and answer session. We're open. It's not too late to ask your question. There's still plenty of time to participate. Just type your question into the text box that's located to the right of the presentation window. Or you can click the Q&A icon. That's at the bottom of the screen. Either way, you just type in your question and hit send. If we're unable to answer every question during the webinar today, we'll share them with our speakers who will reply to you offline. Okay. We do have some questions, so let's take a look. First question, this looks like it's for Nadav. How can I know if my security vendor resilience, how can I know if my security vendor is resilient to adversarial inputs? How can I know if my security vendor is resilient to adversarial inputs?
Okay, so I think that it's definitely depends on the knowledge of the team, whether we're referring in this case to PhDs level and data scientists. I think that potential customers should understand if the solution depends on machine learning as a single layer, for example. And I believe that customers should ask, how does the vendor build the training, which procedures the specific vendor is following the tests, for the validation cycles of the models, how strict is the policy for releasing a new model to production, how did the vendor incorporate generated data sets to combat adversarial samples. I think that in most of the cases, since it's, let's say, a quite new domain, you need to make sure that you're asking these questions as a part of the evaluation cycle or the proof of value phase. Generally speaking, we probably have some of the market leading researchers in the team, which are domain experts in the domain of adversarial networks. And that's it. I believe that if the vendor will be able to address those questions and to elaborate more on how he's dealing with it, you can definitely be able to validate it.
Okay, great. Next question. This relates to something you mentioned during your presentation on poisoning training data, I think using model skewing. So the question is, how can I know if my security vendor is resilient to this whole issue of poisoning data?
Okay. So it's not an easy question to answer. I think that if you really want to dive into details, the best way for doing it will be to start with the session which we shared in the latest DEF CON conference, led by our VP of Research, in which is explaining on how to build the training data sets and how to make sure that the data set is representative, and there are lots of questions to ask if to validate that the data sets are not exposed to any manipulation. I think that potential customers should ask themselves if the vendor compare the inference model of newly trained models to previous models, for example. But generally speaking, I think that it really depends if you are referring to a supervised learning, which we are doing in-house, versus unsupervised learning. But I would start definitely with the session that we shared during the last DEF CON 27 as a part of the AI Village on how to correctly build your data sets and train your models.
Okay, great. Here's our next question. When considering adversarial AI, do you consider how non-AI methods can impact the success of the adversarial methods? I'm asking about non-AI methods.
Yeah, so of course, I think that it's also related to this session, differentiating between things that we are doing automatically in the company and when we are relying on the machine only to take the actions and do it all by itself, versus the expertise that we have in the team from the offensive side on looking on specific attributes and trying to challenge our models. I can say in general that we are doing both.
Okay. Okay, here's another question. It has to do with signatures. What signatures might be found in malware to indicate that it incorporates AI?
So I think that I made it clear in this presentation that we are not doing any manual analysis, and we are not looking for specific signatures that could give us the indication that we incorporates that it incorporates AI. I think that it is very, very difficult for a vendor to understand if the malware that it is facing, if that's the question, is a malware that could potentially be was generated based on a machine. There are a lot of interesting publications today in the industry, and specifically in adversarial networks, of techniques which you can implement in low level in order to make sure that your models are much more resilient. I'm not going to cover it with all the details, but of course, I would say that I think that another good example for dealing with such potential attack is to add potentially another separate neural network, which can just then look for minor changes and to predict if it looks like a potential machine-based sample.
Okay, here's another question. We're getting lots of questions, which is great. All right, here we go. Deep learning approaches tend to reduce significantly larger data sets, the number of training examples, versus traditional machine learning approaches. So the question is, how do you go about labeling so many examples for training? Are you labeling manually or semi-manually or some other technique?
So I guess that this question is referring to the term of ground truth. In our case, we are mainly focused on supervised learning, which is a method that relies on the pre-training labeling. So prior to the training, we should feed to the machine for each and every sample the exact labeling, if it looks more like a malicious sample or like a legitimate sample. And of course, we develop the tools in-house in order to make sure that we are doing it with full automation capabilities. I will just say in general that I can definitely say that it's one of the biggest challenges to have, to know how to label your data prior to the training. I can encourage each and every either a customer or a vendor to doubt the labeling that is existing in the wild. If someone is downloading a potential sample from VirusTotal or other resources, I think that it really depends on the repository, if it's a reliable repository or not. Usually, I would say in close to 100% of the cases, we will not count or rely on any prior labeling on our data sets. We will relabel it in-house based on some tools that we developed in the first year of the company and still validating on a daily basis.
Okay, good. All right, here's our next question. What is the latency of getting a score out of your deep neural network? I understand that each action to be tried by a user has to be postponed until the DNN approves such an action. So how significant is the delay?
So I think that I mentioned it as a part of the challenges that we have as a cybersecurity vendor is dealing with deep learning as a part of the inference model, which we have on the client side, and I'm referring to the performance side. So generally speaking, for an average PE file, which is approximately 1 megabyte, the entire cycle for us to touch the file, run it through the inference model, the deep neural network on the client side, and update if it's malicious or not, takes us approximately 10 milliseconds, which is next to real time. It means that without even touching the file in real time, we can provide with full prevention, pre-execution, and there is zero impact on the user experience in, I would say, the majority of the files. We can do it without any impact on the user.
Okay, wow, that's pretty cool. All right, the next question is for Bruno. Bruno, do you find that the Deep Instinct provides value mainly as antivirus replacement, or does it allow you to get rid of other security products as well?
From our standpoint, it actually allowed us to get rid of other security products, because our previous products, it wasn't a one-stop shop, so to say, so we had to have multi-layered applications on there. So what was happening was the agents were very taxing on our endpoints and on our servers, and we saw huge payback in terms of resources being given back to the endpoints and the servers.
Okay, great. Thank you. Nadav, next question's for you. How small or simple of an endpoint device can operate on your product? How small or simple an endpoint device?
Oh, it's amazing that people are so into it and asking so many questions. So I think that maybe I didn't mention it, but since we are completely agnostic to the input layer during the training cycle, we couldn't care less if it's an APK for an Android device or potential malicious DLL for Windows. And therefore, we are relying on low-end devices to run our solution. It can be a low-end Android device. It can be an old Windows machine. Eventually, it's a small, lightweight agent, approximately 150 megabytes on the Windows and less than 100 on the Android. As a mature solution, I think that it's on us as a vendor to provide with a solution which has minimum impact on the user requirements, and of course on the mobile, minimum impact on the battery life cycle.
Okay, good. We have a few questions in the queue, but I just want to remind everyone in the audience there's still time for you to submit a question to Bruno or Nadav. Just type it into the Q&A area, and we'll read it out. Okay, the next question is for Nadav, and here's the question. Do you feel there to be any inherent advantage in the choice of platform when it comes to resisting an AI-based attack or intrusion attempt? You know, for example, Linux, Mac, PC, with added safeguards in place. So is there any inherent advantage in the choice of platform?
That's a good question. I think that, generally speaking, each and every operating system is exposed to different attack vectors. If we are referring to fixed security solution, then it really depends on the complexity and the effort that the security team was putting on building the models. Generally speaking, I think that an interesting challenge to evade might be an OXML format in which, in addition to the classical features, an attacker can implement any other objects like SWF objects or potential macro files inside. So it really depends on the file format and the complexity of the implementation and things that the attacker can do out of it. I don't think that it is related to the platform. I can definitely say that with Mac OS, of course, the availability of malicious macro file versus the availability in the wild of malicious PE file for Windows, the much more known campaigns on a Windows machine versus Mac OS machine, at least today. For us in Deep Instinct, the interesting attack is the unknown attack, not something that someone was able to analyze before, and something the next malware that an attacker will use. So to address this question, I think that we cannot share a lot about it, but I think that in general, since we are mainly referring to some improvements and challenges that the vendor should do during the training cycle, I think that in order to implement and evade adversarial networks, it doesn't matter if we are targeting a Windows machine or macOS machine.
Okay, great. We're almost out of time, but we have one clarifying question here. I was wondering, when you talked about the small end, did you say 100 megabytes or maybe just 1 megabyte? Because the questioner is saying my definition of a small device would be more like 1. I was wondering if you could just clarify that point.
Yeah, so I referred to 1 megabyte on the Windows machine. Of course, it really depends on what you are trying to achieve. For us, currently, we are not looking on at the moment on IoT devices or an embedded Windows operating system. So I think that for us, I refer to 100 megabytes. It really depends. I don't know who raised this question and if he's referring to a specific device, but they definitely can approach us after this session and provide with more information.
Okay, great. Well, we do have a few more questions. Unfortunately, we're pretty much out of time, and as I mentioned before, we will share your questions with the speakers, who we hope will be able to reply to you offline. And I'd like to thank our sponsor, Deep Instinct, as well as everyone in the audience for attending. We certainly appreciate your attention and participation. Within the next 24 hours, you will receive a personalized follow-up email that will contain details and a link to today's presentation on demand. We hope you'll invite your colleagues and peers who didn't join us today or couldn't join us, and they can view the webinar on demand. This webinar is copyright 2019 by Informa. The presentation materials are owned by or copyrighted by Dark Reading and Deep Instinct, and the individual speakers are solely responsible for their content and opinions. On behalf of our guest speakers, Nadav Mamon and Bruno Mariano, I'm Peter Krass. Thanks for your time and have a great rest of your day.